Have you ever looked up at the night sky and wondered about those distant twinkling lights? What are they? Where did they come from? And what happens when their light finally goes out? These questions are the keys to understanding our own story, the story of everything we know. The universe is a grand stage and the stars are its greatest actors. Their lives are epic tales of birth, struggle, and death. In their final moments, they give us the building blocks of life itself. The iron in your blood, the calcium in your bones, the oxygen you breathe. It all came from the heart of a dying star. This is not poetry, this is physics. So let's embark on a journey across billions of years and trillions of miles. We'll visit cosmic nurseries where stars are born, witness their long lives, and see their spectacular deaths. This is the life story of a star, and it's our story too. Our journey begins in the vast, dark emptiness of space. But this emptiness is filled with enormous, swirling clouds of gas and dust. Nebulae, the raw materials of creation. Imagine a cloud so big it would take you thousands of years to cross it, even at the speed of light. Here, gravity, the silent architect, begins its patient work. It pulls gas and dust together piece by piece over millions of years. This is the first step in building a star. We'll see how a simple cloud of hydrogen can ignite into a brilliant sun. We'll learn how these suns live for billions of years and what happens when their fuel runs out. Some stars fade away quietly, others go out in a blaze of glory. So come with me. Let's step aboard our ship of the imagination and travel to the very heart of the cosmos. The story of the stars is the story of us. Let's begin. Our first stop is a nebula, a stellar nursery. These immense clouds are mostly hydrogen with some helium and tiny grains of heavier elements. For millions of years, these clouds drift through space, cold and dark. But a shock wave or a passing star can disturb them, giving gravity the nudge it needs. Gravity pulls the gas and dust into clumps. As a clump grows, its gravity strengthens, pulling in more material and becoming denser. Over thousands of years, these clumps become large, spinning balls of gas. As material falls inward, it heats up. The center becomes hotter and denser. This hot, glowing ball is called a protostar, a star in the making. It shines from the heat of compression, not yet from nuclear fusion. The protostar continues to gather gas and dust, its core getting hotter and denser. Temperatures soar to millions of degrees. The protostar is on the verge of becoming a true star. Finally, the critical moment arrives. The core becomes so hot and dense that hydrogen atoms fuse to form helium. This process, called nuclear fusion, releases tremendous energy. The energy pushes outward, balancing gravity's inward pull. The protostar ignites. It is now a star. A new light has been born in the universe. From the chaos of a nebula, a star emerges, ready to shine for billions of years. This is the cosmic birth that has shaped galaxies for eons. Every star you see in the night sky began this way. The universe's story continues, one star at a time. Once a star is born, it enters the main sequence, the longest, most stable phase of its life. Our sun is a main sequence star, shining steadily for billions of years. Here, the star is in perfect balance, gravity pulling in, fusion pushing out. Deep in the core, hydrogen fuses into helium, releasing energy that makes the star shine. Every second, our sun converts millions of tons of hydrogen into helium, with a tiny bit of mass lost as energy sunlight that warms our planet. The star continues this process as long as it has hydrogen in its core. The lifetime of a star depends on its mass. Massive stars burn bright and die young. Small red dwarfs burn slowly and can live for trillions of years. The main sequence is the quiet adulthood of a star's life, but eventually even stars run out of fuel. The next chapter awaits. All good things must end, even for stars. After billions of years, the star's core runs out of hydrogen. Without fusion to balance gravity, the core collapses and heats up. The outer layers expand, the star swells to hundreds of times its original size and cools to a reddish glow. A red giant is born. Our sun will become a red giant in about 5 billion years. As the core collapses, it gets hot enough to fuse helium into carbon, the triple alpha process. This new fusion gives the star a brief second wind. But helium runs out quickly, and the star is now racing against time. The red giant phase is dramatic but short, setting the stage for the star's final act. The end is near, and what happens next depends on the star's mass. The universe is about to witness a spectacular finale. For stars like our sun, the end is gentle. When helium runs out, the core collapses again, but it's not hot enough to fuse carbon. Fusion stops, and the star becomes unstable. The outer layers are ejected, forming a glowing planetary nebula, a beautiful, colorful shell of gas. The hot core left behind is a white dwarf, about the size of Earth, but with the mass of the sun. A white dwarf no longer produces energy. It slowly cools and fades over billions of years. Eventually, it becomes a cold, dark black dwarf. This is the quiet, peaceful end for most stars in the universe. The elements released enrich the cosmos, ready for new stars and planets. The cycle of creation continues. But for massive stars, the end is explosive. These giants fuse heavier and heavier elements, building up layers like an onion. When the core becomes iron, fusion stops. Iron can't release energy by fusion. The core collapses in a fraction of a second, triggering a titanic shockwave. The star explodes in a supernova, outshining its entire galaxy for weeks. The explosion forges elements heavier than iron, gold, silver, uranium, and blasts them into space. The supernova remnant becomes the raw material for new stars, planets, and maybe life. This is both an act of destruction and creation. The universe is forever changed by each supernova. After a supernova, what remains depends on the star's mass. If the core is between about 8 and 20 times the sun's mass, it becomes a neutron star, a city-sized ball of neutrons, incredibly dense and spinning fast. Some neutron stars emit beams of radiation, pulsars. If the original star was even more massive, gravity wins completely. The core collapses into a black hole, a point of infinite density where not even light can escape. Black holes are detected by their gravitational effects on nearby stars and gas. These are the universe's most mysterious objects, the ultimate fate of the most massive stars. They remind us of the awesome power of gravity. The story of a star can end in silence or in the most extreme objects in the cosmos. We've traveled across the cosmos, witnessing the birth, life, and death of stars. But what does it all mean? The answer is profound. The stars died so that we could live. Every atom in your body, except hydrogen, was forged in the heart of a star. The carbon in life, the oxygen you breathe, the iron in your blood, the gold on your finger, all made in stars. These elements were scattered across the galaxy, forming new solar systems, planets, and life. We are, quite literally, stardust. When you look up at the night sky, you're seeing your cosmic ancestors. The story of the stars is our story. Let it spark your curiosity. Ask questions, explore, and keep looking up. The universe is full of wonders, and our journey has only just begun. End of Scene 8.